All right, so chapter 19 is our last chapter on Equilibria. And this is the most intense chapter, and that's because we layer on so many things that we've talked about from previous chapters. So to give you a highlight, even though there's 5 skills that we'll talk about, there's 3 main things that we're doing in this chapter. We're dealing with buffers, so we're dealing with quantitative and quantitative aspects of buffers. We're dealing with titrations, so we're dealing with qualitative and quantitative aspects of titrations. And then we're dealing with salts that have sparing solubility, which means they're not completely soluble. They're not going to completely dissociate in solution. And so we're going to think about, again, the qualitative aspects of buffers and titrations, and then we're actually going to have some of the most intense and lengthy sort of calculation problems that we do when it comes to thinking about calculations with buffers and calculations with titrations. So just as a little bit of a preview about how this stuff comes together, in our last chapter we learned about acids and bases. And what we're going to learn about right now is if you have a weak acid and its conjugate base in solution, that creates a special solution that we call a buffer. And buffers are resistant to changes in pH, and we're actually going to be able to do some calculations that think about, well, if I have a buffer solution and I add some extra acid in there, how much will the pH change? So again, we'll talk about qualitatively how and why the pH will change and why it might change only minimally compared to like a pure water solution. But then we're actually going to take the time to do the calculations and figure out exactly how much the pH is changing. So we'll do that with buffers. And then the thing with buffers and those calculations is we're adding just one lump sum of something. With titrations, what we're actually doing is we're dripping in that amount that we're adding. So we'll start, for example, with a pure acid solution, and we'll drip in base. And then we'll see how the pH is increasing, how the concentration of species is changing over time. And so we're going to have a fairly elaborate kind of worksheet that we'll have to keep track of all of this. We're going to be using both ICE tables and ICF tables because sometimes chemistry is happening and then we have to consider the equilibrium that's happening with the reagents and the materials that are left over. So it is a really intense chapter. Really complex equilibria that we'll consider. So it's important that we really master chapter 18, which is why our quiz is going to be on what's the pH of this solution, because oftentimes that's a starting point for us to begin these more complex problems. Again, the last little piece that we'll talk about is solubility of salts. So maybe some of the salts that in Gen Chem we told you were insoluble, we'll really realize that they're sparingly soluble. So we'll think about maybe moving in a forward direction, how much of the salt dissociates and how much is in solution. Or we can actually think about this from the reverse direction. What concentration would we need to build up to in order to have these ions precipitate out of solution? And this has a lot of application in water chemistry and all kinds of other kind of aqueous chemistry. So a dicey chapter. We're going to have some lengthy problems that we'll work through in class, lengthy homework problems. And again, this last chapter on Equilibria will represent the last content that you'll have before your next exam.